Assalamu alaikum wa rahmatullah. This is your Kamal sir, mostly known to you as a triangular Kamal sir. Today I am going to solve a 13-week physics assignment for the students of standard 9, and this assignment from the chapter 2 motions. This is one of the most important creative questions from the chapter 2, and you can apply these questions in the assignment also in the upcoming any exam. So dear students, here you have to answer two questions by using the figure, how to find the accelerations by doing the mathematical calculation, and you have to solve the question. So let's see how we can solve this. Okay, first we will review the questions here and what is our requirement. Then we will try to answer step by step. And there are total 3 questions. First question, explain the velocity, uniform velocity and acceleration with the figure. The second questions, there is a diagram is given here, the figure, the different positions of an object or particles, so and at a different times. And what is the requirement? Find the total distance traveled by the particle and determining acceleration and decelerations at distance OA, AB, BC, and CD. Then the next questions, question number 3, and question number 3 here, analyzes the change of velocity with the help of graph. And with the help of graph, so by using this graph, you have to explain the velocity of the particle. So times and velocity is given here. Okay, now, inshallah, we will try to answer step by step. Okay, this is the 13-week assignment plus 9 assignment physics English version. So first question's answer. Okay, here the first question, explain velocity, uniform velocity and acceleration with figure. So now first we have to define what is velocity, then we will explain with the figure. Velocity is the rate of change of the object's position with respect to the frame of reference and time. Basically, speeding in a specific direction, it is a vector quantity, which means we need both magnitude or speed and the directions to define the velocity. The SI unit of it is meter per second, and formally it right here ms. You can write here m as inverse 1. So this is the unit of the velocity, ms inverse 1. So now here this is the figure. So now if we change here, suppose in the right direction there is a time, and in this the y-axis, here we can write here the distance. Now with respect change of the distance with respect to time, if we write here change of the distance with respect to time, so this one will be the velocity, and distance unit is the meter, time unit is the second. That's why we can write ms inverse 1. So now this is the figure of the distance with respect to time, the change of distance with respect to times. So now second questions, review here the uniform velocity. So now, okay, the uniform velocity, if the value and the directions of the velocity of an object remain unchanged during the motion, then the velocity of that object is called the uniform velocity. That is, if the object crosses the same path at the same time in a certain directions, then the velocity of the object is called the uniform velocity. That is, there is no change of velocity with respect to time. That is the fixed. So this is called the uniform velocity. So now, next definitions here, define accelerations. So now, I think here the first we will define acceleration. Acceleration is the rate of change of the velocity of an object with respect to time. That means velocity change with respect to time is called the accelerations. A point or an object moving in a straight line, that means direction is given here, is the accelerated. If the speed ups, that is called the acceleration. If the speed slow down, this is called the negative accelerations or decelerations. The SI unit of the accelerations is the meter per second square. I think you can write like this, ms inverse 2. That is because the velocity ms inverse 1, velocity divided by time. So here we can write here ms inverse 2. So this is the unit of the accelerations. So now here, suppose this is the distance. So if we write here unit of distance divided by time, you will get here the velocity ms inverse 1. But if you write here, in absence of the distance, if you write here velocity ms inverse 1 velocity, then change of velocity with respect to time will be acceleration. So in the first figure, you can write here the distance and time, and in the second figure, where you will define the definition of accelerations, and you have to write here velocity, and x-axis will be the time. So change of velocity with respect to time is called the accelerations. So the same figure you can write, no problem. So now second question, one of the most important questions here, not only in this assignment, but also in any upcoming exam in SSC or test exam or the 9th standard any exam. So this is another most important questions from the chapter 2. Now we will review here first questions, then answer. So now here the question is, find the total distance traveled by the particle by determining the acceleration and decelerations of the distance OA, AB, BC, and CD. There are two requirements. First step, we have to identify acceleration and decelerations of the both OB, OA, OC, and CD. Then we have to find the total distance. Okay, first, let's explain the graph here. In the x-axis, we see here the time is given here 10 seconds, 20 seconds, 30 seconds, 40 seconds. In the y-axis, we see here the velocity is given here 5 meter per second, 10 meter per second, 15 meter per second, 20 meter per second. That means velocity and time. So change of velocity is given here with respect to time, and this is acceleration. So I think the graph is given here, the accelerations. We have to explain the change of velocity with respect to times. In the first one, O to A, the line is OA, O to A. This is the upward line, increasing line. At the 10 seconds, we see here position of the particle is at A, while the velocity is 5 meter per second. And here it started from the velocity 0, and at the point A, we see here in the 10 seconds, change of the time is 10 seconds to 0 second, and change of the velocity is 0 to 5. So here acceleration formula, final velocity minus initial velocity and change of the time. So acceleration at the distance OA. So doing the calculation, you will get here 5 divided by 10. This one will be actually 0.5 ms inverse 2. So I think I have missed here. Okay, now at OB, OA done. So now see here A to B. We see here the time changes 10 seconds to 20 seconds. That means now time 10 to 20 seconds, but the speed of the car, that means velocity is not changing here. The velocity here at 10 second velocity here is 5, and at 20 second also velocity here up to 5. That means there is no change of velocity at the time 10 seconds to 20 seconds. So here we can write the acceleration in the second figure, acceleration will be okay. Now at the distance AB, the final velocity is 5, initial velocity is also 5. So now 5 minus 5 divided by 10, that means the 0. So from A to B, that means from A to B, the particle has no accelerations. So that means it means the object is moving at uniform velocity in the distance AB. There is no change of the velocity with respect to time. That is, this is the uniform velocity and the fixed velocity. So now, and the next positions are B to C. In the B to C, again, if we see the graph at 20 seconds to 30 seconds, the velocity increased 5 to 10. Here at the position B, the velocity is 5. At the position C, the velocity is 10. That is, there is also change of velocity. That means we will get here accelerations. So acceleration here, the ending time is 30 seconds, started from 20 seconds. So change of the time is 10 seconds, and change of the velocity is 5. So doing the calculation, this is 0.5 ms inverse 2. So now here the next part, C to D. We see here from the C to D, the graph is downward. That means the initial point is here C and ending point is here D. At the initial point, the velocity is given here 10. At the ending point, the velocity is 0. So I think here the final velocity is 0 and initial velocity is 10. The change of the time is 30 to 40, that means 10 seconds. So here 0 minus 10, the negative value. So negative value divided by 2, we will get here 1. And that means negative acceleration means decelerations. So that means there is an speed is gradually decreasing here, and that's why the acceleration is the negative. You can write here decelerations or negative accelerations. So now second, our requirement already acceleration and deceleration done step by step. Now the question requirement, find the total distance traveled by the particle and 0 to D. 0 to D. Here total 1 part, 2 part, 3 part, and 4 part. So now we have to find the distance A to O to A to B, B to C, and C to D. Then we will add 4 distance successively. Here O to A acceleration done. So now by using the formula S equal to ut plus half of at square, U means starting, initial velocity is 0, T means change of the time is 10 seconds, and 1 by 2 at square, A equal to on the first part we have shown here OA, here acceleration is 0.5 and the time is 0 to 10 seconds. That means okay, after doing the calculation, there here the particle travel 25 meter. So now in the second A to B, this is the uniform velocity, there is no acceleration here. So you can write here the distance A to B as equal to B. Also you can use here the formula as equal to ut plus half of at square. There is no problem. U means starting, initial velocity is 10 and the time is here 10 to 20, that means 10, and here then plus half times of the acceleration is 0 and the time is also 10. So here 10 multiply there is U means 5. I have done here mistake. U will be 5 here. This is 5. Initial and ending velocity all are 5. So 5 to the 10 here. So I think if you apply this formula instead of S equal to ut plus half of at square, your answer also will be okay, no problem. Here also the result is 50, and so also you can apply S equal to Vt, no problem. Now from the distance, this is AB done. So now the second distance, this is not actually AB, this one will be B to C. This is B to C, the distance BC. Okay, now again use the formula here. We see S equal to ut plus half of at square, and here S means, U means initial, starting, this is from the 5, T means change of the time is 10 seconds, and half of at square. So from the previous part you can apply at the BC that acceleration is 0.5 and time is 10 square. So after doing the calculation, B to C, you will get here total distance is 75 meters. So now just from the first part, just apply the value here, A equals to at from the first part. So now from distance, this is the distance AOA done, AB done. The second distance is AB done, and this is BC done, and then another distance is the CD done. So just I have copied this. This is CD, another distance CD done. So now C to D. Here the C to D as equal to ut plus half of at square. So I think U equal to 10 here. Started from the 10. and t is the 10 second, 30 to 40, and half. A is the deceleration, there is the negative acceleration -1, and the time is also given here 10 seconds. So C to D, the car or the particle travel 50 meter. So now, according to the question requirement, find the total distance traveled by the particle, the total distance OA, AB, BC, and CD, and put their value. All are the meter, 200 meter. And this is our answer. The particle travel total 200 meter, or the car travel 200. They didn't mention here name of the car. So just you can write here the particle move total 200 meter. So now I hope this question is very clear to all of you. Now another important question, analyze the change of the velocity with the help of the graph. There is time is given here. There is time is given and change of velocity is also given. And now explain the graph here. Okay, first we can see the figure here. O2P velocity is given here 2, 4, 6, 8, 10, 12. The time changes is given 2, 4, 6, 8 the second. There is a distance OP, PB, PQ, and QR, RS, ST, and TU. So the 1, 2, 3, 4, 5, 6. 6 steps you have to explain one by one. Okay, let's review the first step. OP. O2P, here we see here the time is 2 seconds and the change of the velocity is 0 to 4 meter per second. So here acceleration done because with respect to time, velocity changed here. So now explain the first one. Okay, at the distance OP, the particle is moving uniform at uniform acceleration. Here the velocity is 4 ms inverse 1. So you can write here ms inverse 1. So now acceleration O2P will be final velocity minus initial velocity, 4 divided 4 by 2, change of the time, change of the velocity, that means so at OP. So now here the second step, review here the second step, P2Q. P2Q, here we see here P means at 2 seconds the positions of the particle is at P, and position of the particle after 2 seconds is at Q. That means at 4 seconds the position is at Q. So now here the change of the time is 2 seconds. Change of the velocity is 4 to 12. That means 12 is ending velocity and initial velocity is 4. That means here also acceleration is done because with respect to time, change of velocity is occurred here. So at the distance PQ, the particle is moving uniform acceleration. Here the velocity is increased. Actually moving with the acceleration, uniform acceleration, the velocity is increased 4 meter per second to 12 meter per second with respect to the change of the time 2 seconds. So now here accelerations will be final velocity minus initial velocity divided by change of time, 12 minus 4, then time 4 minus 2, there will be 4 meter per second. So now the next step here, Q2R. What we see here at the point Q, here the velocity is 12. At the point R, here is velocity is also 12. But 4 seconds to here we see here total 10 seconds at the positions R, there is 10 seconds. But the time it changes here, the particle, the time, moving time 4 seconds to 10 seconds. That means time it changes here. But the velocity is not changed here. The initial velocity is 4, ending velocity is also initial velocity is 12, ending velocity is 12. So now that means there is no velocity at QR. Here the velocity is 12 meter per second to 12 meter per second at the time for 4 seconds to 10 seconds. So time changes 4 to 10. The velocity is not changed here. So now we can write here. So there is no change of the velocity at the distance QR. So the particle is moving at uniform velocity. This is the uniform velocity. So now acceleration will be 0. Where is because no Uniform velocity means there is no change of velocity. No change of velocity means acceleration 0. So here from Q to R, the acceleration will be 0. So now let's review here the graph. Just after 10 seconds, the particle is reducing its velocity. Just after 10 seconds from the positions R, just after 10 seconds from the positions R, the particle came at 1 second at velocity 8. Then after 1 second is reduced with velocity 4 meter per second. Then again after 2 seconds it's reduced its velocity again 4 to 2 meter per second. So we see here from 0 to up to R, here 3 steps, the velocity change of the velocity is increasing. That means the first step, second step is increasing, and third step is uniform velocity. But after 10 seconds, the velocity is decreasing here. That means the particle is losing its velocity. So now here initial velocity is 12 and terminal or ending velocity is 8. That means ending velocity is reduced. That means this is deceleration. There is no acceleration, it's negative acceleration. So now right here in the graph show, explain, in the graph show that the after 10 seconds, that means here after 10 seconds means this point, the velocity of the particle is gradually decreasing. So here from R to U successively or consecutively, the particle will give the negative acceleration or decelerations. So now just at RS, R to S, there is 10 seconds and S is just at 11. 10 second to 11 second, the change of time is 1 second, but the here initial velocity is 12, ending velocity is 8. So now final or ending velocity, there is the negative acceleration, that means decelerations. So now in the same way, S to T here in the same way, the deceleration is 4. Now and the final step here, the final step T to U, that means the change 4 to 2, the reduced its velocity 4 meter per second to 2 meter per second, and change of the time is 2 seconds. So here decelerations or negative acceleration is -1. So dear students, I hope all of you have understood this content properly. I have tried to represent this assignment to easier to you. So that's why I have drawn so many diagrams and to explain all the steps properly. And if you love my content, please subscribe my channels and you can share to this content to your friends, and wish you all the best. Hope to see you all in the next content. Assalamu alaikum wa rahmatullahi wa barakatuh.